right, to finish up our topics from Chapter 8, I want to talk about today accuracy. Now, I am going to use our Monopoly data set just to finish off this example, even though we've established that linear regression is not appropriate. We saw that from our residual plot. But again, just run with this last example using Monopoly. So what we can do to measure accuracy, right? Did we make like a good model? Is what we call R-squared. Here's a couple important facts about R-squared. It is literally R, remember R, correlation, squared. It tells us what percent, okay, so there's a clue. We're going to report R-squared as a percent. What percent of the variability is explained by our model? Okay. Important word here, variability. There are differences, right? That's what makes our world interesting. The monopoly properties cost different amounts of money. So what I want to know is what percent of that difference in cost can be explained by our model, by the relationship between the number of spaces from go. So again, what I'm really explaining here is the differences in cost, or variability in cost, is explained by our model, or in other words, the number of spaces. Okay. We've noticed that it seems like the more spaces you travel, the more it costs, but there are other explanations. So we're going to see what percent is explained by the distance we've traveled. So I like to call this my no-bake cookie recipe. If you've ever baked before, if you've ever watched me bake before, it's a disaster. I have a really hard time baking cookies. I can never seem to get the amount of flour right, and they end up coming out a little strange. But no-bake cookies, man, you just follow that recipe and you cannot fail. So I call this a no-bake cookie recipe because if you follow this recipe, you cannot fail in your explanation of R-squared. An R-squared value of fill-in-the-blank percent means that, fill-in-the-blank percent, of the variability in, fill in your y variable, is explained by the linear model. Follow that, you cannot fail. So where do we get this mysterious R-squared number? And let's practice the no-bake cookie recipe with this example of Monopoly. So just to remind you, we can get a lin reg by going to Stat, Calculate. I always use option 8, and then we tell it the two lists we're using. Always go in X, Y order. So I have L5, which is my number of spaces, comma L6, which is the cost. And check it out, right on this screen, you'll see an R-squared, okay, right here. So it looks like in this situation, our R-squared is 0.77. I'm going to change that to a percent, so that's 77%. All right, so for my Monopoly data, my R-squared is 77%. So I'm now going to explain. An R-squared of 77% means 77% of the variability, remember that just means differences, in my y variable is cost, is explained by the linear model. In other words, explained by this relationship to the number of spaces. 77%, that's a lot. That's a little over 3/4. So 3/4 of why a property costs a different amount can be explained by knowing how many spaces away it is from go. Now, there are other things, right? 77%, that's not all of the explanation. So there could be other reasons, right? Other explanations. Okay? Some of it might have to do with the type of property. Railroads are always the same amount, no matter where they're on the board. So that's one explanation why the costs are different. And there could be others. That's just the one I could think of off the top of my head. So 77%, that's a lot. That's most. But there are other explanations for the variability or the difference in costs. I'm going to do one more example for you, and I'm going to leave one for you to try. We've seen this story problem before. Some people say you can estimate the temperature outside based on the number of cricket chirps. So here was the equation of the line that best fit that data set. And I just made up a number. Suppose the R-squared for this story problem is 0.42. So we know that we're going to call that 42%. By the way, your calculator always does a lowercase r. I always write a capital R. Not a big deal either way. All right, so I'm just going to follow that no-bake cookie recipe. An R-squared value, 42%, means 42% of the variability. Again, if you don't like the word variability, substitute it with a word like differences. 42% of the variability in my y variable. That is the temperature outside, as explained by the linear model. So 42%, about half of the reason that it's a different temperature outside can be explained by knowing how many crickets are chirping. Very interesting, very interesting. All right, and the last example I'm going to leave to you, again, we've seen this before. Perhaps there's a linear relationship between the number of baseball games won by American League teams and the average attendance. So I've included for you the model, just to help you remember which is the x and which is the y variable. And again, I just made this up. Suppose the R-squared value for this story problem is 0.83. Would you please interpret that R-squared value? Remember to do it as a percentage.